Electromagnetic radiation, past exam questions. Let's go ahead and take a look. The first question, write down two properties of electromagnetic waves. So, what are those things that are always true for all electromagnetic waves? Well, we know that they travel with a speed of 3 times 10 to the power 8 meters per second. You just don't write 3 times 10 to the power 8 meters per second, but you write it in full. They travel with a speed of 3 times 10 to the power 8 meters per second. Apart from that, we know that they can travel through vacuum. They don't need the medium to propagate. So that's another property of electromagnetic waves. They travel through vacuum. So those are just some of the properties of electromagnetic waves. Let's go ahead and take a look at the second question. Which radiation has the highest energy? So from the information given, the table below shows an arrangement of electromagnetic radiation according to their frequencies, from radio waves to gamma rays, and we have the accompanying frequencies. So the question is saying, which radiation has the highest energy? We know that the higher the frequency, the higher the energy. And from the table, it is easy to see that gamma rays have the highest frequency. So they should have the highest energy. So the answer to question 2 is gamma rays, because they have the highest frequency. And the higher the frequency, the higher the energy. The third question, a certain radiation has energy of 1.99 times 10 to the power minus 20 joules. Identify the type of radiation associated with this energy. So we are given the energy. The question says that we must find the type of radiation associated with this energy. We are given a table of type of radiation and type of frequency. So we will use this energy that is given to calculate the frequency. And after calculating the frequency, it is just a matter of identifying in which range it belongs. What type of radiation is it originating from? So let's go ahead and take a look. So we know that the energy is equals to Planck's constant multiplied by the frequency. The energy is 1.99 times 10 to the minus 20 joules. This is equals to Planck's constant, which is 6.63 times 10 to the minus 34 multiplied by the frequency. So we're going to divide both sides by 6.63 times 10 to the minus 34. So let's just go ahead and do that real quick. And then on the right hand side, it's easy to see that this 2 will cancel out, and we're gonna have the frequency being equals to 1.99 times 10 to the minus 20 divided by 6.63 times 10 to the minus 34. That is 3 times 10 to the power 13 hertz, being equals to our frequency. So there we go. Now it's just a matter of figuring out in which range this frequency belongs to according to our given table. We have 3 times 10 to the power 13. So it doesn't belong to radio waves, as we can see, not microwaves, but infrared. As you can see, this is times 10 to the power 13. And infrared is ranging from 10 to the power 11 to 10 to the power 14. So 10 to the power 13 is in between the frequency of infrared. So the answer here is actually infrared. The question is saying, let's identify the type of radiation associated with this energy. It is clearly infrared.